Hi there, guys. Well, welcome back. We're about to do 3C, which is developing and using the quadratic formula. So this one will be relatively short, I think. Okay, well, interesting little point over to the side here. It says, when solving quadratic equations, the solutions are called roots, since the formula you use, in the formula you use a square root to find them. Yeah, I mean, you can think of it like that. There's definitely a square root involved. I also think of it in a slightly different way. Now, clearly it does come from that, but if we're talking about trying to find roots, well, it's a bit like if this is the ground, then this is where the roots begin. If you were talking about trees, for example. Okay, that's a kind of stupid analogy, perhaps. But either way, there's square roots in them. So therefore, we call these zeros roots. In other words, the solutions to these things equaling to zero, so the x values that makes an answer of zero, these things are called roots. Okay, right. So most of you are probably familiar already with the quadratic formula, and you can see that if we set up a quadratic in terms of a lots of x squared plus b lots of x plus c, where x is your variable, and where a, b, and c are just constants or parameters. They are belonging to real numbers here. And they're saying as well that a is definitely not equal to zero. So we have to have x squared involved. If a was equal to zero, then we'd have a linear function, okay, or a linear equation. Okay, so it turns out that through completing the square and a ton of algebraic rearrangement, you get down to this. Now, I'm not going to go through that here, but I noticed that the book does go through this. It says, look, here we go. You can come up with your steps here, some explanations here as well. And that's a nice little investigation. And I would expect any HL math student to be able to take that first line, so the ax squared plus bx plus c equals to zero, and get down to the formula in the last line. And they're even giving you tips there as to how to get there. But I think you should be able to do all of that working out yourself. Now, if you're not feeling quite up to that at the moment, then listen into the next little bit, because I'm just going to do this for a simpler version. Just take a little bit of grey so I can write on this. So a simpler version of a quadratic would be x squared plus bx plus c is equal to zero. Same conditions, b and c are real numbers, but here we just have a is equal to 1. So I've just reduced it down to the cases where a is equal to 1. And by the way, you could do that for any quadratic equation, because if we had the a there, we could then divide everything throughout by a, and we could have our coefficient here being b over a, and the coefficient here being c over a. So we could use this new formula, which I'm talking about, which I'm about to develop. Okay, if that doesn't make sense, maybe I'll do a question at the end. Okay, so where do we go with this? Well, first of all, we complete the square. And remember, the completing the square technique is to take half of b, so your coefficient of x, and square it. And that will deliver you with these two terms, but it will also deliver you with an extra b over 2 all squared, which we don't want. That's extra to our requirements. It's not here. So we're going to take away that. And by the way, whether this is plus or whether this is minus, we're always taking away that. I mentioned that earlier, but it's worth saying again. And we've got the plus c here is equal to 0. Now we can multiply out our brackets here. So we've got b squared over 4. We can make the c into 4c over 4. So I'm just making an equivalent fraction there, essentially timesing the top and the bottom by 4. Minus here, the 0 on the other side, and we've got the x plus b over 2 all squared there. Now, how much should I do in one step? If I put these together, I'm going to get b squared minus b squared plus 4c all over 4. And when I take that to the other side, that's going to mean that b squared is actually positive, and we'll get the minus 4c. And both of those things are divided by 4. So I've essentially taken this and this to the other side, but both of those are over 4. So I'm going to combine that as a single fraction. Okay, if you want, you can take 2 steps for that. And you know, the more steps, the better, really. There's always room to write more steps in exam papers, and yeah, it saves you from making mistakes the more steps that you do. Okay, well, next little step is to take the square root to undo the square here. So square root from here is b squared over 4c divided by 2. So we're taking the square root of the top and the bottom. You know, that's something that we can do. There's laws of indices or laws of surds, if you like. So we're allowed to do that. And remember, in a equation situation, we'll need to have a plus or minus on there, which I can either incorporate into the top or the bottom of the fraction. I'll put it into the top there. Now we have x plus b over 2 is equal to this. Now you can see we have the same numerator there conveniently. So we're going to bring the b over 2 to the other side. So we'll get minus b over 2. I'm just going to save. So I'm squeezing it into the corner here and save the divide by 2 into putting it there. Okay, so that's me just taking this to this side and combining the 2 fractions. Okay, so that's going to be equal to x. So this formula should be looking kind of familiar to you. It's kind of like the quadratic formula. Quadratic formula, remember, is minus b plus minus. And although you get given this, you should remember this, of course. So b squared minus 4ac divided by 2a. So the a pops up there and there in this formula here. Okay. As I said to you a moment ago, let's just give ourselves a little space over here. As I said a moment ago, if you had something like, I don't know, 2x squared minus 5x plus 1 is equal to 0, then if you divide it throughout by 2 to start off with, you get 5 over 2x and plus 1 over 2 equals to 0. Then you could use this formula here. Yeah, there we go. So that would be the formula which you could use, and you could then say, well, this is B and this is C. So you could use that reduced version. Anyway, I'm not suggesting that you do that because, of course, you've got your regular formula, which is given in this bracket here. Okay, so there's the formula x is equal to minus b plus minus, etc. Okay, so the last line there that we're getting, x is equal to this thing, is basically telling us the numbers, which if we substitute them back into the original equation, will end up giving us a 0. So let me just say that one again, just to make sure this is really, really clear what we're up to here. The numbers that we get out from this, when we substitute them back in to this thing above, say for example, we get out 2, that's one of our numbers. When we put them back in here, we'll get a 0, okay, because this and this are equivalent expressions. It's the same equation written in a different way, in fact. Okay, so they should get the solutions that we get from this will then be the same ones which when substituted into the original version will give you a 0. Hopefully that's pretty obvious. Okay, so I'm not going to go through all of these ones because they're pretty tedious. And all of your calculators have got the option to do these as well. But I'll just go through perhaps one of these. It says leave your answers in exact form. And obviously, if you haven't seen this before, you really need to get some practice. And so when you're leaving your answers in exact form, we need to leave square roots in the answers. But let's deal with part C here. So we can say that we've got A is equal to 5, B is equal to minus 2, and C is equal to minus 1. So we've got minus 2 gives us plus 2, plus minus b squared, so that's going to give us minus 2 squared is 4, so that's minus 2 all squared. And remember, if you're typing this into your calculator, you're going to need those brackets there. So otherwise, it's going to give you minus 4. Okay, remember that this is not the same as this. They're not the same thing. So we want to substitute things in using brackets. I'm just doing a kind of quick version of this, of course, as ever. and then we've got 4ac. So that's 4 times 5 times minus 1. Again, when we're substituting things in, I would always use brackets rather than putting the times in between. Just you can now type into your calculator brackets as well, and so it will still work it out using the brackets when you type it into your calculator. Okay, and on the bottom we've got 2 times 5, which of course I can do like this, but I'm just going to say is equal to 10. So there we go. That's first part, and then we can say we've got plus 2, just 2 of course, and let's work out what's inside the bracket here. We have, oh, this is interesting. Seems to me that we don't have, this is a negative number. Oh no, it's not a negative number because this becomes positive again. Oh, apologies. So we've got 20 times minus 1 is minus 20. Another minus there, so that's 24 plus 20, 24 there, and then we've got over 10. Now that's our final answer, but we can simplify this somewhat. We can see that there's a square number in the factorization of 24. So I can see that 4 is in here. I can see that 24 is the same as 4 times 6. So if I take that 4 outside of the square root sign, then I need to actually square root it, and I'll get the answer of 2. So I've just extracted a square number from my square root, essentially. Now that's surds, and again, I think you should have done surds before. So all I'm saying there is we can split surds up into 4 times 6, and we can split this up into the square root of 4 by the square root of 6, and then the square root of 4 is actually 2. Okay, leaving us with the 6 inside. So if we take a 4 out of 24, we're left with the 6, but when we square root it, we get 2 on the outside. We've got 2 there, plus minus this thing, over 10, and you can see now that we could factorize out 2, okay, and then we could cancel that with a 2 on the bottom. Or in other words, let's divide top and bottom by 2. So we're getting 1 plus or minus square root of 6 over, not 2, over 5. Okay, now that gives us 2 solutions. That gives us the first solution, so x1, if you like, is going to be equal to 1 plus square root of 6 over 5, and x2 is going to be 1 minus the square root of 6 over 5. We've got 2 solutions. We can put a comma in between them if we want to. Let's have a look at what the book does. Okay, so see at the end it says x is equal to either 1 minus square root of 6 over 5, or, but they've just said x is equal to the other one. So they haven't called them x1 and x2, but you certainly can do. Okay, well, I'm not going to do anything more with that. I think that the questions are just simply practice. What's interesting, perhaps, in the case of part D, which is why we're building up the complex numbers, is that they say here that x doesn't belong to your real numbers. So have a quick look at this one. Your final answer is this. That's fine. But if we're talking about finding real solutions here, so numbers which are on the number line for x, and not numbers which are somewhere on our Argand diagram, in other words, complex numbers, then this would not be a valid solution. Now, if we're allowed to use complex numbers as well, then we can definitely say that take this a little bit further, and we can say, well, we've got minus 1 there, plus or minus, and we can split the square root into the square root of minus 1 times the square root of 7, and then we can change this into I. So then we can say our 2 solutions are minus 1 plus minus square root of 7i, or I times the square root of 7 divided by 4. There's our 2 complex roots. That's leading to our fundamental theorem of algebra, which is turning up later. Okay, right. So it does just mention that sort of pretty obviously when either of the coefficients b or c are equal to 0, we have special cases. And I mean, what's turning up here in these brackets are just super obvious, but this hugely algebraic way of defining this. And it's great if you can read that. That's fantastic. But I mean, I just think it's kind of overcomplicating things a little bit sometimes, in which we don't need to do. So, for example, all they're saying is if we get something like, I don't know, x squared I don't know, let's say 2x squared minus 32 is equal to 0, well, we can take the 32 to the other side. We can divide by the 2, and we see we've got x squared is equal to 16, and then we can then say x is equal to plus or minus the square root of 16, so plus or minus 4 there. So actually, we don't need to do anything fancy if we're missing that middle term. Now, what you'll notice is that if your answers are nice at the end, like if I just divided everything by 2 to start off with there, you could also do this by using the difference of 2 squares. Okay, there's a square, take away a square, and so the format for this, if I say a squared minus b squared, you should know that that can be put in brackets by saying we've got a minus b and a plus b. Again, that's just the use of the difference of 2 squares format in order to find the 2 roots there as well. And I'm hoping that you're aware of that from before. And if you're not, then just type into Google difference of 2 squares, and obviously you'll find plenty of videos and everything. Okay, so for this one, we can again say, look, x has got to be equal to 4 from the first bracket or minus 4 from the second bracket. So again, those are our 2 solutions. Okay, and when we were talking about the other case of having the c is equal to 0, so again, let's come up with, say, x squared plus 5x is equal to 0, just ignoring this for a moment. This has got a pretty easy solution as well, because, well, first of all, if there's a number in front, you could divide throughout by that number. But given that you've now divided throughout by that number, you can now say, let's take out x as a factor here. You can do the factorization. You can say, well, either this has got to be equal to 0 to make it 0, or this bracket is equal to 0 to make it 0. So the x is equal to 0, or from the second bracket, x is equal to minus 5. So that will make a 0 there, and anything times by a 0 is 0. Okay. There is a temptation in this one. This is a common mistake for people to say, take some of this back, let's just call that a minus 5x. Okay. So for people to say, let's take the 5x to the other side, and let's cancel an x. And there we go, we get x is equal to 5. But you'll realize that you've lost a solution there, because there's another solution here where x is equal to 0, because 0 squared is equal to 5 times 0. So you've got to be really careful when you're dividing by your variable, because sometimes your variable can equal to 0 as well. And that can also be a valid solution. So just be careful of dividing throughout by x. It's much better if we can factorize. Okay, next one then. So we've got example 5. And here we go. So this one says, solve the quadratic equation. Gives us a quadratic equation in terms of p's and x's. X is our variable, and p is this parameter or constant. And it says p is non-zero, so it's definitely a quadratic, and it says by using the quadratic formula. So let's do it then. So we've got px squared. It's best to keep that positive. So let's take the x's to the other side. So we've got 3px plus x, and then we've got the plus 3 there as well. Now, we can see that if we factorize this, the x out of the middle term, the 2 middle terms here, then you're going to get 3p plus 1 lots of x plus 3. Okay, so now we can say a is equal to this, b is equal to this, and c is equal to this. We can substitute those into the formula. So we're going to get minus b is going to be 3p plus 1, plus minus, we've got b squared, so 3p plus 1 squared. Now you'll notice that I've missed out the minus sign there, because when we square a negative, it's going to be positive. So I don't need to worry about that minus sign on the outside. You could put a minus 1 there if you want, but then when you put the brackets around the whole thing, that minus 1 is going to be plus 1 anyway. Okay, and then we've got minus 4ac, so we've got minus 4 times p times 3. I haven't used brackets there, which is what I was telling you to do, but no negatives, no harm. Okay, and we've got 2 there, and we've got the p here as well. So that's 2 times a, so 2p. That's going to be equal to x. If we take that a little further, of course, we've got 3p plus 1 plus minus, and now in the brackets we've got 9p squared plus 6p plus 1 minus 12p. And again, I'm going to skip a step here. Apologies about this, but I'm just going to say that's minus 6p plus 1, just to save myself a bit of space, but obviously don't do that yourself. Okay, divided by 2p. And I don't know if we can take that any further. Maybe this factorizes. Maybe this is a perfect square, kind of imagining that it might be, because I mean, when we're doing the square root, I'm hoping that this is going to simplify a bit more. So let's have a look. I'm imagining it should be 3p there, and then in order to get a plus 1 in the end, it's going to have to be minus 1 here, all squared, because we're going to get a minus term turning up. So let's just check that one out. When I multiply that out, I've got 3p squared gives me this, that's fine. This squared gives me this, and the 2 middle terms are going to be 3p times by this, minus 3p, and we'll get that repeated when we square this thing. Okay, now again, I'm skipping steps a little bit here, but when we square root that square, that's going to undo that square. It's going to take that one off. So we've now got to this situation here. Okay, that's pretty messy. Okay, divided by 2p. And now we can hopefully simplify this, and we'll need to simplify it by doing 2 of these. Let's just take it up here. Okay, so we can do the positive version of this and the negative version of this. Okay, so maybe let's take them either side. So the positive version is going to be 3p plus 3p. It's going to give us 6p, and it's going to be equal to x, first solution. So that's going to give us 6p, and 1 plus minus 1 will cancel, so that's going to be 6p over 2p, which is going to give us just 3. Oh, that's pretty nice. And x2 is going to give us 3p minus 3p, because we're following the minus now, so that's now minus 6p. Sorry, no, it's not at all. It's no p. And then 1 minus minus 1 gives us 2. Put 2 over 2p, which is 1 over p. That's interesting. Let's just check that we got that one right. Okay, let's see. Yeah, we're getting 3 and we're getting 1 over p. That's really interesting that we're getting a number which is not dependent on this parameter at all. That's just coincidence, really. Okay, but there we go. There's our solutions, and we're done then. Obviously, you can check out the working out, which they've done in the book as well. Okay, right. So there's 3C, and next time around, we're going to look at the discriminant of a quadratic equation. Thanks very much for listening, guys, and hope to see you back next time.